Hello and welcome to Sifasoc Academy The Intellect on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. And we do it in all the science subjects because we are a team of teachers that performs and functions best. In this video, we are looking at June 2020 Advanced Level Physics Paper 2, Section 1, Question 2. And before I continue, I'll invite you to subscribe to the channel and activate the notification bell to not miss any of our videos that will upload subsequently. So the question read in figure 1, a charged metal sphere A is hung from an insulating string. Another charged sphere B on an insulating rod is then placed close to A as shown. And I've shown the diagram. There's a diagram here. The charge on sphere A is positive 5.0 nanocoulomb, while that on sphere B is negative 4.0 nanocoulomb. Roman 1, draw the two spheres and show the electric field pattern around them. Roman 2, determine the magnitude of the electric force between the two spheres. Roman 3, what is the value of the angle theta if sphere A has a mass of 4.5 times 10 to the negative 5 kilogram? Okay, let's go directly to the solution. The electric field around the two spheres. Now, to remind you, the electric field around a positive charge sphere is always going out of the sphere. That is the electric field. The arrows are always pointing outward. Meanwhile, that of the negative sphere, the arrows are pointing inward. So when we combine it like this, we'll have that the arrows, it will seem like the arrows are leaving from the positive to the negative side because they are close to each other, yes. But initially, we know that for a positive charge sphere, it is going outward, it's moving outward. But when it's close to a negative charge, then the arrows are going towards the negative charge. Okay, Roman 2, the magnitude of the electric force between the two spheres. To calculate the magnitude of the electric force here, we'll simply use the Coulomb's law. But I will not state it, we'll just write the mathematical expression. F will be K, cure A, cure B all over R squared. That's the distance, the square of that distance of separation. So we have K as 8.9 times 10 to the power 9 Newton per meter coulomb squared. Is a constant. It's called a Coulomb constant. And cure A is 5 times 10 to the power negative 9 coulomb. Cure B is negative 4.0 times 10 to the power negative 9 coulomb. Then R is 3.5 times 10 to the negative 2 centimeters or meters. Is meters because in the question they gave 3.5 centimeters, but now to convert it into meter we have 10 times. We have 3.5 times 10 to the power negative 2 meters. Okay, simplifying directly or substituting directly into the formula, we have F is equals to 8.9 times 10 to the power 9 times negative 4 times 10 to the power negative 9 times 5 times 10 to the power negative 9 all over 3.5 times 10 to the negative 2 all squared. Now, we have that it is equals to negative 1.5 times 10 to the power negative 4. Now, we are calculating the magnitude of the electric force, but the answer I gave us is negative. So, we need to do the magnitude of this force here. And we know that the magnitude of the force is, or we know that the magnitude of a negative number is positive. So, we have that the magnitude of the force, F, will be 1.5 times 10 to the power negative 4 Newton. So, question 3, or Roman 3, they said the value of theta when A has a mass of 4.5 times 10 to the negative 5 coulombs or kilograms. So we model our diagram first. Here we have the tension T. Now, sphere A has a mass, it means that it has a weight. So first we have the angle theta, it means that sphere A has a mass, means that you have a weight. Now we now resolve the tension. Resolving the tension horizontally, we see that the horizontal part here is opposite to the angle. So I have here T sine theta. The vertical part is adjacent to the angle, so I have T cos theta, and then the force is acting on the left side. So I have F is equals to this. Now, resolving the tension and balancing the force, we have that vertically we have T cos theta is equals to mg. We are seeing that to balance the forces, the upward force needs to be equal to the downward force. We have that T cos theta is equals to mg. We call it equation 1. Then, horizontally, to balance these ones, we have T sine theta is equals to F. We call that one equation 2. Now, we want to find the value of theta, not the value of T. So, we can divide equation 2 by equation 1 to get, that is equation 2 divided by equation 1. We have that tan theta is equals to F all over mg. And we have calculated F subsequently as 1.5 times 10 to the power negative 4 Newton all over 9.8, which is G, times 4.5 times 10 to the power negative 5 kilograms, which is equals to 0.33 after an appropriate calculation. So we are not asked to find tan theta. It means that our theta is tan inverse of 0.33, which is 18.26 degrees. So guys, we have come to the end of this video, and I'll invite you to like the video, comment and share. Now your comments are very important. If your comment is in the comment section, that you can tell us your impression and which kind of videos you want us to do, like which kind of questions you want us to treat. And we don't forget that in science, consistency is the key.